Good morning, ladies and gentlemen. My name is Todd Jobson, and if you haven't had a moment to take a look at my bio, I bring more than 25 years of experience to the table across a wide range of industries and organizations. And I would have to characterize the last 10 years being spent primarily on digital transformations, large enterprise-wide data center consolidations, cloud enablement, and a lot of the paradigm shifts that we're going to be discussing today, I have extensive experience within. So hopefully I will impart some wisdom upon you folks, some lessons learned as we go through this presentation. The content that we're going to be going through centers around securing your digital transformation and considerations for enterprise architecture and cloud enablement. Let's jump right to the outline here. The content's going to be broken down into 4 sections. I'm going to start off discussing at the highest level what is digital transformation and how it relates to enterprise architecture and security. Next, we'll go through today's state of enterprise security, a little bit of a history timeline, a characterization of some of the largest breaches, and then what's changed within the security landscape and where we're headed. The third category of content is going to bring you up to date with essentially a brief history and time of how we got to where we are today in terms of technology, and then walking through the paradigm shifts you see listed here as bullets 1 through 6 individually, discussing how these paradigm shifts are intersecting throughout the industry and causing a lot of disruption. So we'll talk about some of the individual challenges and benefits of each of these overlapping and layered paradigm shifts. And then the end of the presentation will be a summary of more or less key lessons discussed and recommendations moving forward in terms of adapting your enterprise architecture to enable successful and secure digital transformation. So that section will have a summary of both the business and the technical aspects in terms of challenges and recommendations for digital transformation and how enterprise architecture and architectural principles overall that we've discussed throughout the deck relate. So with that said, let's jump right into the content. The first section regarding digital transformation at the highest level, I wanted to start off and lay a landscape of common theme we all run into. So take a look at the graphic at the bottom of this slide and look at the top portion. That's the optimistic vantage point that most go through within organizations when they start and kick off any new project such as digital transformation. Everyone's optimistic, they have their goals in sight, they have a clear path and a clear plan, and they think everything is going to go smoothly. Well, then we look at the bottom half of the slide, and it actually depicts the reality. We typically run into a lot of obstacles, roadblocks, challenges along the way that we really need to adapt the process, and up front, if we can address and expand our horizon of assessment and factor in a lot of the alternative options and complexities, we can make things a lot smoother. So the last comment there is, something you should think about in the back of your mind. You probably already do. But ask yourself, do my expectations in the hype of what we're proposing as strategic initiatives really match what the reality is going to be? And in planning, we've got to do a thorough assessment, we've got to temper expectations, and we need to plan for those contingencies along the way. So again, at the high level, what is digital transformation? It's difficult to characterize in one sentence. We know there are a lot of areas and aspects ranging from business and technology. But I think at the core, the synopsis can be summarized, as I stated here, managing the successful utilization mapping and implementation of technology to optimally fulfill strategic business initiatives, and of course while achieving several benefits. And the benefits I list out in the middle of the slide. But digital transformation in and of itself offers a lot of complexity, and the complexity, the changes, and the benefits fall within two key areas, and those are business versus technology. And on the business side, what's going to change a lot starts out at the top with your business model, your outlined strategy, strategic initiatives, and ripples all the way through the operating model and everything underneath it, the organization, people, process, services, governance, and so on. And then the flip side of the coin is the underlying technology to support those strategic business initiatives, which includes, your applications, your data, your infrastructure, your process and automation of that infrastructure, your tools, repository, security, and so on. So the key point here being you need to address both sides of your digital transformation, not just focus on the technology, but also factor in the business aspects throughout your assessment and future state planning. To touch on some of those benefits, I'm not going to read through the list. You folks can do that afterwards. But the key benefits and key challenges can always guarantee disruption. Disruption, whether it's positive or negative, is going to be a guaranteed side effect of transformation. And that disruption comes in those two forms, the positive being creating new markets or displacing your competition via the implementation of your new technology. The negative side is, of course, going to be the disruption that impacts your business, the changing operating models and organization, the rehiring of people, the retraining, the implementation of new technology, and so on. We'll go through those complexities and challenges in the coming slides, but managing that disruption is a key facet and component of successful digital transformation to help you manage that complexity and the rapid changing pace of things that need to get adapted to moving forward. Looks like my screen just caught up. I apologize for that. Okay, digital transformation facts. At the highest level, Gartner went out, interviewed 2,600 CIOs to establish, how much traction digital transformation has in the industry. And they came back last year with a number that's pretty compelling, that out of all CIOs surveyed, 30% of their budgets are being devoted to digital transformation. And that's been rapidly gaining traction and growing over the last several years, and it's going to be doing the same thing, I predict, in the coming years. It's here to stay, and it's something that needs to be embraced, and a lot of thought and planning and rethinking how we conduct our business and architecture needs to go into how it's implemented. The second bullet, you probably need to brace yourselves, fasten your seatbelts before reading, but the reality of digital transformation and its implementations is that most, or 85% of all digital transformation strategic initiatives have resulted in failure in one form or another. And this comes from a Forbes study. The link is there in this slide last year. So transformation offers a lot of benefits, but at the same time, there are a lot of pitfalls and obstacles and challenges. And if folks go into it headstrong without a lot of planning up front, failure is a definite possibility. So a lot of what we're going to talk about relates to how to mitigate that failure and make sure we're successful. The last bullet, number 3, that I want to point out is going to reflect some of the key points and themes that are going to be in the following slides throughout this talk. And that is that most organizations, 2/3 in this study, admit they've struggled adequately implementing just simple cloud, mobile, or big data analytics technology. That's not even the full landscape of all the converging paradigm shifts we're going to talk about. So most organizations just struggle implementing new technology, and at the same time, the other facet is that they're struggling with the pace of change of technology and the speed of digital change. And that's a large portion of what we're going to talk about, is how technology has been rapidly changing and how that change impacts our businesses. This last slide on statistics around digital transformation shows another study from MIT Sloan, and this is just about 6 months ago, so this is recent data, and it shows, after asking organizations to characterize themselves against two metrics, that of operational efficiency or customer experience, we can see here that more than half, and by far the largest category, characterize themselves as still living in the past, the land of legacy, siloed environments, with a lot of complexity as their obstacles to implementation. So if you look at the future-ready, transformed upper right quadrant, you can see less than a quarter of organizations feel that they are future-ready. And all of these statistics go together and confirm one another as a key concern today that needs to be addressed. And how do we address that? Well, one of the best ways to address it is with the appropriate framework and methodology, and that's where enterprise architecture comes in to play. This slide is supposed to characterize and summarize enterprise architecture in a single slide, and we all realize we could spend hours discussing what enterprise architecture is. But I've summarized it and related it to digital transformation at its core in the following sentence: being able to provide an architectural framework and methodology for managing the process of mapping the optimal technology to successfully fulfill strategic business initiatives. So at the core, you can see this is the counterpoint to the summarization of digital transformation and its goals and objectives. So enterprise architecture is there to help enable, manage, and define your future state architectures that you're moving to. What I did was I took a look, and I've worked with a lot of methodologies, a lot of frameworks over the last decade, and I thought the easiest to grasp in a single couple of slides or graphics was Oracle's implementation of TOGAF, and TOGAF being the #1 enterprise architecture framework and process. Oracle's implementation summarizes it nicely into these two graphics. On the left, you can see the enterprise architecture framework starting at the top with business architecture. So that would be identifying all your key business strategic objectives, priorities, how they map and relate to the business and operating model within the organization, strategic initiatives that need to get kicked off, SLAs, current state needs, and so on. And then below that, the business architecture overlays everything else that supports it, and that being the application architecture, information and data technology, and the underlying framework of technology and infrastructure to support everything above it. At the left, you see the people, the process, the tools that are needed throughout all those areas of architecture and implementation. And then on the right, you see governance that's tied back into the business governance. So you can manage everything from steering committees and process and policies and so on appropriately. And then at the bottom, every enterprise architecture has a repository. And one of the key benefits of enterprise architecture being to standardize and manage reference architectures and implementations so that you have proven, tested configurations that can be reused and continuously improved and most importantly, deployed into production with more certainty that you can predict the outcome of versus uncertainty of just throwing out new configurations without the appropriate level of planning. On the right side is its counterpart in terms of process. And this process, again, reflects most enterprise architectures that are out there. And it starts off at the top by mapping those business strategic goals, objectives, priorities at the business layer to create an architectural vision for the customer, where they want to be in the future, what capabilities they need. And walking through the process clockwise, it starts out with some discovery. You would meet with the key players, the key groups within the organization, lines of business, to define what the current state is. That current state's going to include everything that is within the layers on the left that support the business architecture that's outstanding today. So systems, networks, databases, applications, integration points, and so on. And at the same time, the current state assessment needs to capture compelling events, issues, concerns, problems in the past, so you have a little history of what's happened that sometimes reflects the culture, the process, and how everything has come together. So above and beyond the technology, a lot of what's discovered can identify some issues that you're going to likely encounter in the future so that you can address them before you encounter those issues. And then after the current state discovery, you're going to do some future state architecture planning. So you will take those business needs requirements, SLAs, strategic initiatives that point to the ultimate future vision, and you're going to create alternative architectures that bring those capabilities to light in the optimal fashion, utilizing the latest technology. And at the same time of identifying alternative future state architectures, you have to factor in how you get them there. So migration, integration, what's existing, what's going to stay, and what's going to go away are also facets of this assessment process. Typically what we do, especially when it comes to cloud enablement or large-scale data center consolidations where migration is required, we need to take a step back and outline all of the components within the current state architecture and do things such as an application portfolio assessment, where we rationalize which applications and application environments can be end-of-lifed or should be, versus which ones are required and what their SLAs and mission-critical relevance is, so that we can appropriately adopt the latest and appropriate future state architecture for those environments. And we'll get into some of those logistics, some of those caveats as we move through the rest of the content. But after identifying potential alternative future state architectures, we would create a roadmap with timelines. We would adapt the existing governance for the future state implementations, and then we're going to come back to the key business owners at the executive level with a business case that shows what we're proposing, what the findings and recommendations are, and from the business vantage point, the financials. Does it make sense? What's the return on income? What's the total cost of ownership comparison between the different alternatives versus where you are today? So that is enterprise architecture in a nutshell. The next slide shows the industry standard frameworks and methodologies that have been in place for a long time. On the left side is a summary of TOGAF, and on the right side is ITIL depicted and how it maps to TOGAF, and ITIL being the #1 IT service management methodology and framework. And at the bottom, the takeaway from this slide and the segue into the remaining content is the red bullet at the bottom. And that is, today, formal enterprise architecture and service management can be at odds or in conflict with one of the largest paradigm shifts that's been underway for the last few years and is here to stay, and that is agile methodology and rapid deployments. So we'll talk about that later, but adapting enterprise architecture so that it embraces agile methods and things like DevOps is a key facet of being successful with digital transformation. This next section focuses on enterprise security and gives us a vantage point of where we've come from and where we are today in terms of security. This first slide showing a timeline for the past decade plus of cyber attacks. And as you can see, and the real takeaway from this slide are two things. The first question being, in 2013, when the number of cyber attacks increased dramatically, what occurred then? And the other question being, what was different before 2013? And as you can see on the left, that green circle represents a decade prior where there were not, a fraction as many cyber attacks. So I guess to characterize the differences, I'll just say at the highest level, what was different back then? Well, we know things weren't really connected as much to the internet. Most of the enterprise processing that existed within organizations happened deep behind multiple layers of firewalls. And they also ran typically on siloed legacy big iron deployments. Things like IBM mainframes and Sun Solaris systems and other large vertically scalable footprints that didn't involve open source or publicly accessible access points to that physical hardware from the internet. And then, of course, as we move to the right, mobile computing came into play, mobile applications, the ability to inject software into a handheld device, voluntarily, that you don't really understand the ramifications of. That's where we are today. But the other key point, and what's circled in red on the right around 2013, is an event that occurred. Some say this has relevance. I believe it does. But again, it's a question of what actually happened. But in 2013, a gentleman by the name of Edward Snowden was working for the NSA for several years, and he decided to basically defect from America and bring with him a laptop that had lots of NSA information and tools on it. And in 2013, he was stopped in China. His laptop was taken by the Chinese government, and then he proceeded, since China wouldn't enter him into mainland China, he proceeded to Russia. And then Russia went through the same process. They held him, they took his laptop, and it might be coincidence, but a lot have reported that those tools that were on his laptop could have had some influence on the explosion, especially from Russian and Chinese hacking that's really escalated from that point forward. But not him specifically, just the fact that there are tools out there, that open source is really an open door that you need to examine very thoroughly. Those are all common characteristics that enterprises need to explore and investigate. This next slide I'm going to go through pretty quickly, given the time, but this just shows you on the right some of the largest security breaches in terms of numbers of records or personal identities that were stolen throughout 2017. And you can see the numbers not in the millions or hundreds of millions, but we're talking billions of citizens, some of the largest being in the U.S. Probably half of the U.S. had their records stolen just from the Equifax breach alone. And that included things like Social Security numbers, driver's licenses, date of birth, things that if someone with malicious intent wanted to create a fake identity and buy a car or a house with, they would have the means. So again, extremely alarming statistics, It's on the increase, and it's something we need to be aware of. And on the left, the only takeaway that I want you to realize is the fact that the malware to conduct these attacks, one interview was conducted around ransomware, and the security expert said it's so easy to get the software, you can get it as cheaply as $1.04 on the dark web to conduct ransomware attacks on companies. So the tools are out there, they're essentially free, and we need to do our diligence to appropriately plan and stop this type of security intrusion within our organizations. So the next slide outlines, again, I'm not going to read through all the bullets here, but on the right side it outlines what's changed. What are the key challenges and what are the key considerations that we need to make moving forward as part of digital transformation? So specifically related to security, the technology's changed. On the upper right red circle, you see the key things that have changed in terms of technology. Yes, we've got new systems and processors and operating systems and so on. But the adoption of free and open source software has been a theme that has really gained traction to the point of becoming a standard in the industry. It's something that's here to stay again, and it's become a standard. But at the same time, when everyone in the world has access to all the software and the source code, hackers can spend a lot of time in their basements going through and identifying vulnerabilities that they can attack. And that software is being downloaded today in every enterprise, and it might not come in the form of complete packages, although it typically does. It could just come in the form of libraries that are utilized by other packages that enterprises are compiling against. And any of those functions could open Pandora's box to vulnerabilities within our organization. So again, we've got to do extreme vetting when it comes to the use of open software. The second counterpoint to that is mobile applications. Again, both open source software and mobile applications give hackers one of the best vehicles, aka Trojan horses, to get their exploits onto your personal devices or behind corporate firewalls. And once inside, it's very easy to laterally move from system to system to find the data that they're looking for. And then lastly, the last two bullets in that upper right box, availability and power of penetration and hacking toolkits. We just showed you for $1, you can get an entire toolkit that you don't even need to really understand how to use that will go out and create ransomware attacks. And then lastly, the number of public security vulnerability dashboards has been increasing and has gotten to the point that literally within hours of a vendor identifying a security vulnerabilities, these hacker dashboards will reflect those vulnerabilities in ways that can be exploited. So the hackers are out there, they're up to date. The other side of the scenario are the enterprises that utilize that software. So patches are identified, but patches typically don't get deployed immediately unless they're addressed and identified by a vendor as triggering some sort of a security vulnerability alarm. So we need to do diligence there as well to ensure that everything is patched as soon as those patches are available. And then the bottom right reflects what we're going to talk about in a moment, what's changed, and the fact that we've gone from those legacy, vertically siloed, big iron deployments to thousands of VMs. That additional complexity to stay on top of the latest patches that need to get deployed to keep all of those thousands of VMs up to date is a lot of overhead. It's a lot of change, and it's something that requires a lot of rigor, time, and resources to do. Luckily, the industry is creating tools to automate that, but we're not quite there yet. So patching is of key concern and something that you really need to focus on very closely to shore up these vulnerabilities. The next slide goes over, I think, one of the best characterizations of open source and Linux OS security vulnerabilities. And it's a quote that came from the gentleman who was the MC of the 2016 Container Summit. Now, I'm sure we've all heard of containers. It's one of the paradigm shifts, one of the cloud deployment services that has gained a lot of traction with people moving from VMs to containers for various benefits that we'll discuss in a moment. But this gentleman that was the MC of this open source container summit, he was asked about Linux security and container security, and he stated, and it's outlined here above, that the Linux kernel was never really designed to meet security needs. And then he talks about Docker, and Docker is the biggest standard for containers today. And this is just 2 years ago. He stated that that week he was interviewed, Docker released the first version that really addressed user-level namespaces that enables any kind of security within Docker containers. And then he also further went out on a limb and he said multi-tenant security is not really there yet. And then he concluded by saying you're one vulnerability away from real devastation, and agreed we will get there, but there are a lot of gaps in both Linux deployments and the open source and container communities. So again, this is validation of what we talked about a moment ago, and it comes from the gentleman that was the MC of the Container Summit. The next slide, I'm going to let you read in your spare time, but it just shows you, it rewinds us back to 2016, a little more than a decade ago, and it shows us the state of enterprise software and free and open source communities. And it shows how things have changed over the last decade to the point of the world really being turned upside down in just 10 years, moving from standard, proprietary, common off-the-shelf software deployments to predominantly now open source deployments, open source variations of software, again predominantly Linux. And it shows how companies like Sun Microsystems have gone away, even though they were dominant back then. And it also shows how organizations like Google and Apple have really filled a huge void and overtaken the world. So in just 10 years, technology can literally change in a heartbeat. This next slide just shows you typically the standard security process and framework that enterprises have been working with. This goes back to 2012. On the left side is the NIST standard cybersecurity framework, and on the right side it was a Gartner variation of their predict, prevent, detect, and respond cycle. And they're both very similar. They both show a continuous monitoring, continuous improvement, recursive process, starts with identifying and ends up by giving you capabilities to predict and recover from any security incidents. But then if we move to the next slide, you can see how things changed very rapidly, where this year Gartner modified their security architecture framework to recommend and actually quote and predict that by 2020, which is only 2 years away, 40% of large organizations are going to have an established security data warehouse to support advanced security analytics. And what does this mean? It's essentially saying that one of the biggest paradigm shifts, the move to AI and machine learning, is going to be adopted and infused throughout the industry, but more specifically here for security tools to give you that predictive analysis based on machine learning and actual environments. So this is a big shift that we can all expect and we need to adopt in terms of security. That moves us into the next section that goes through brief history of technology, how we got to where we are today. And the takeaway from this slide is that we need to do our diligence and not always just believe the hype or follow the pack. And the quote from the Game of Thrones, I think, is spot on, that typically belief can be the death of reason. And if we take a step back and think about that, once you just assume that something is good, you're going to deploy it and turn it into a standard within your organization. So we need to always step back and look at the big picture in doing thorough analysis. So as we can see here, technology has gone through a lot of paradigm shifts. Today we're somewhere down in the middle of where the blue meets the green on the left of this slide. But it shows that technologies that were once in their infancy, that were just thoughts, they were new emerging technologies that didn't have a lot of adoption, they eventually get so much momentum and traction that they become standard. So we've gone through the internet paradigm shift, social media, mobile devices and mobile app adoption, cloud enablement, big data, and now we're going through the rest of those that are in the green. If we move to the next slide, it breaks down a lot of these technical paradigm shifts and new technologies into what's today coined as the Gartner hype cycle for technology. This is one of the first versions that came out in 2012, and it shows us that on the left, when technologies first come out, there are a lot of expectations. You get up to the peak of the hype cycle where expectations are at their peak level of inflation, and then you go through a period of disillusionment where some of the expectations haven't been met. So this shows you just back 6 years ago, cloud computing had just broken beyond that inflated peak of hype and expectations to gain traction to the point where today it's on the right side. It's become a standard form of technology that's adopted. The next slide shows us where we've come from, and this is a key point that relates to complexity and some of the challenges that we pointed out earlier that organizations are all going through and will go through as part of digital transformation. This shows over the last 2 decades data center expenditures worldwide. This was an IDC white paper and survey that was done across all organizations or a large swath of organizations. And it shows you, if you follow the black line, shows you the number of logical server deployments, essentially virtual machines or VMs. And it also shows you in red the amount of effort and dollars spent on managing and maintaining those environments. So on the left side, if you look at the bottom, we came from those legacy siloed deployments of big iron, proprietary OSs and proprietary software, operating systems and software that was not open source or visible to the external world. Then we went through in the middle period right after a large recession in 2001. We had a lot of worldwide turmoil, and companies as a result had to cut budgets. So at that point in time, commodity, cheap hardware, x86, Linux, and open source software, was an optimal path for organizations to move to versus very expensive proprietary hardware and software licensing. So that shows you right after that period and point in time, virtualization was adopted throughout the world. And at the same time that the number of VMs escalated, complexity and cost to manage and maintain those environments, those thousands of VMs instead of hundreds of physical environments, it related to a lot of cost and a lot of headaches. The explanation can be seen on this next graph. On the left side showing fully integrated stacks that are the typical 7 layers that you deploy things upon. You're going to have your physical infrastructure, server storage, VMs, OS, database, middleware, and applications. And it shows you the complexity that's related to the number of variations at different layers of the stack. So this showing if you've got one vendor's deployment with one single variation, you have one thing to worry about: maintaining, configuring, patching, deploying. Your standards are set, and there's not a lot of variation. There's not a lot of unknowns that can happen by deploying that environment. As you move to the right and you create very complex and unique multi-vendor configurations, you end up with permutations and combinations that order in the tens, if not hundreds of thousands of possible combinations of configs. So this just shows you the complexity that comes into play when you allow folks to just mix and match what they call best-of-breed configurations and throw them out into production. It becomes unmanageable. That's one of the things that enterprise architecture is there to resolve. This is just a depiction on this slide showing you those best-of-breed solutions require separate vendors for support for each of these layers, separate support contracts, teams of folks that need to be experts across each layer, and that adds a lot of cost and complexity. And one of the stories that I tell people, one of the lessons that I learned, relates to root cause analysis. If you have several vendors that you need to call to figure out what your problems or root causes for an outage were, that complexity can add to the time of an outage and add a lot of real cost. This slide that you're looking at now shows what happened after that period is the hardware vendors, the software vendors got together and said, hey, we need to abstract all this complexity. We need to create single pane of glass management technologies, things like VMware, and we need to converge all of these hardware components. And that's when we went through the period of converged and hyper-converged infrastructure and now private and public cloud deployments that are extensions of those converged environments. This graphic shows you why people want to go to the cloud today. You know, what's the promise of enterprise cloud as part of digital transformation for organizations? And it shows two key facets. The top left and top right bullets being agility and then platform standardization. So this reflects clearly that organizations had a lot of pain with complexity in managing their environments, and they also had an issue where it took a long time to deploy things to production. So they didn't have agility in developing those environments nor managing them. And that brings us to the remainder of the presentation that goes through these multi-layered paradigm shifts that are underway today. And today we're actually at a very critical inflection point where complexity is at its pinnacle and diligence needs to really be stepped up a notch in terms of planning. So the first paradigm shift organizations are going through, I'm sure you're all experiencing it, is the Agile movement. So in terms of corporate or business agility, everyone wants to move more quickly. Back in 2001, something called the Agile Manifesto was created for software development to promote the adoption of methodology for software deployment that later turned into DevOps that recommended small teams working on small components of software working in parallel for very short periods of time that they called sprints. If you've heard of Agile sprints, you probably have them in your organizations. You realize that that process, that methodology, really upsets the prior methodology and formal process of enterprise architecture and business planning. So this goes back to the point earlier where we showed how Agile can really be conflicting with enterprise architecture or formal process and planning. To the point of today, Agile's turned into, at the bottom, the DevOps movement and also cloud-native movements, which relates to application re-architecture. But Agile and DevOps, in and of themselves, can lead to a fracturing of governance very easily. that poses, again, another obstacle to digital transformation that needs to be addressed up front. It's a cultural thing, but it can have very broad ramifications. And the graphic on the right just shows you the typical water flow process versus multiple agile sprints. This next slide goes into paradigm shift number 2 that we're all feeling and going through, and that is of cloud adoption. Cloud adoption and enablement is here to stay. This is a very recent survey done by RightScale, and it shows you that only 5% of enterprises don't have plans for cloud enablement and cloud adoption. So 95% of organizations are either here or will be cloud enabling in the near future. And it also shows something that's very recent. Just in the last couple of years, multi-cloud is one of the latest buzzwords. And that reflects that organizations don't just want to go to one public cloud deployment or solution provider, or they don't want to just deploy things on premises in private cloud deployments. That they're all deciding that multi-cloud is the way to go, to leverage one vendor against the other so that they don't have lock-in from the cloud providers. And also on the right, it depicts that half and likely more than half of organizations are going to have hybrid cloud deployments in the future to leverage that multi-cloud model, as well as a point between their on-prem private cloud deployments and public cloud deployments, essentially an integration point. So next shows the options and part of the decision process that organizations need to go through around cloud deployment models. Well, the first thing that you need to do is realize you need to get off your traditional silos, or in most scenarios, unless it's an extremely mission-critical platform, you've done the assessment, you realize due to compliance, regulatory, and security needs, you cannot migrate from those legacy siloed platforms. For everything else, if you want to cloud enable, you need to first go through that second box in blue, which reflects consolidation to virtual deployments. You need to go through the physical to virtual consolidation process. And that's really the first step. Next, to the right, you see what's deemed 3 options for cloud deployment, being private cloud, which is typically within your own network, behind firewalls, within your own data centers, cloud enabling your infrastructure as a private cloud. Second being public cloud deployments up in the provider's data centers that typically are shared multi-tenant environments with other customers, although most cloud providers today do offer bare metal options. And then lastly, the hybrid and multi-cloud deployments that we talked about as integration points and a happy middle ground between private and public cloud deployments. The next slide shows you the second facet and the second area that you need to make a decision on, and that's the service models to deploy your cloud-enabled applications to. What service models do you want to utilize? And this comes down to a question really of, you can see at the top, complexity and control versus simplicity and very little control over the environments. On the left side, you see an on-prem deployment where you've got control of everything from the firmware all the way up to your source code and applications. And as you move through on the right 3 tiers, from infrastructure as a service to platform as a service to software as a service, you go through greater levels of abstraction where the service provider is taking care of more and more of those underlying layers. So infrastructure as a service, you will typically be allowed to spin up instances of VMs or bare metal systems, but the provider is going to manage the virtualization of physical systems, the networks, the storage underneath that. So what you're given as an abstraction is a software-defined view of that infrastructure, and that's infrastructure as a service. Platform as a service moves to the right even further, where the service provider maintains everything from the runtime, the middleware, the OS virtualization on down the stack, and all that the customer needs to do is manage the applications and that data. And then to the right, we have software as a service that Salesforce.com made famous initially. Now everyone else, Microsoft 365 and so on, are utilizing as software as a service deployment models for applications where a client just gets an interface for an application and the vendors and cloud providers manage everything else. So as we move forward, this is really the crux of what needs to be thought through on this slide in terms of cloud fit to determine what's appropriate for your deployment and service models within your organization. They fall in 4 quadrants: latency versus security versus control versus cost. And again, typically you can't have all 4 of these. An on-prem deployment that you have full control over using more vertically scalable, larger types of hardware where you have more cores and so on. That's going to give you optimal performance, better latency. Well, the alternative is shared VMs in a public cloud provider's deployment. You're going to have additional latency. You're going to have multi-tenant latency. You're going to have network latency going over the internet to access those systems. So that needs to be considered. To the right, you've got security considerations, compliance, regulatory needs, isolation, whether or not you can have tenancy to meet your SLAs and regulatory requirements. Then you also have specific security frameworks that you might have to accommodate. Not all cloud providers and environments accommodate and are certified against all of these security frameworks. So that's another consideration. And then what we talked about earlier, control and cost. Most people are moving to an OpEx model where you can rent that computing capacity as VMs in a public cloud environment. But again, that needs to be evaluated. And then, of course, control. How much control do you need over your environments? I'm going to speed up the next few slides so that we can get to a couple of these key concepts. But the next one shows you where we're at today in terms of cloud service models and how it impacts application architecture. And that's really a revolution that's underway for service models right now, where folks had just accepted virtual machines as a standard runtime environment for their workloads. Well, now the paradigm shift is to move to containers. And containers, Docker being the number one type of container, containers also offer specific advantages, but it's got some key characteristics that offer and add additional complexity. And that's where managed Kubernetes comes in to manage the orchestration, the registry, the service discovery, the networking components of container management. And then lastly, serverless is a big word that we're all hearing now. It's essentially taking the software, instead of running your full application stacks on VMs, containers offers specific services to run in standalone containers. Well, now serverless is offering you a platform as a service model where you can run only those functions, single functions, and access them via APIs up in a cloud environment. So they are ephemeral, very short-lived functions that are called typically via REST APIs, and there are ramifications. They're very short-lived, so monitoring and access to those environments that live less than a second can be extremely difficult to monitor and manage. This slide shows you some of that additional complexity in moving from VMs to containers. And then beyond that, we show where we're at today in the industry in terms of adopting different service models and growth areas. And it shows you on the left, software as a service is of course number one. Infrastructure as a service has been rapidly growing, but platform as a service, the middle bar in each of these, is rapidly catching up to infrastructure as a service. And that's something that people thought might not happen because there was a fear of vendor lock-in of platform services. And then on the right side of this slide, it shows you that serverless and containers as a service is here to stay. Even though containers will deploy your services or microservices in an environment that's shared by many other containers with a single operating system core, that if it went down, all those containers would have issues for availability. Even though there are those caveats and additional complexities, they're being addressed today with things like Kubernetes, and the adoption, the momentum is there and gaining pace. So containers as a service and serverless deployments is on the rise, and it's something here to stay that you need to be aware of. This slide shows where we are today. I'm going to try and wrap this up pretty quickly in relation to cloud security. Cloud security, you can read this in your spare time, but it offers a lot of rethinking of security versus the siloed deployments on-prem. Essentially, everything is virtualized, so you have software-defined virtual components up in a public cloud environment. On the right is Oracle's OCI public cloud environment. It's very analogous and similar to what Amazon, Azure, and IBM and others offer. Essentially, it gives you multiple availability domains or zones, which are separate data centers within different regions where you can deploy your workloads. And it gives you a virtual cloud network that bounds your environment, and it gives you virtual firewalls on Amazon. They're called security groups, and all the other components within a software-defined setting that allow you to have role-based access control and identity and access management integration, even to the level of federated with your on-prem single sign-on environment. So that's something that requires a lot of training and rethinking if you're not familiar with today. Migration alternatives. There are a lot of considerations. You can read through this in your spare time. I have a lot of articles that talk about this on techthought.org. But the key note here being, if you're thinking about refactoring your monolithic application environments to microservices, be aware there's a lot of complexity involved. And that's the last thing that I'm going to touch on here that we have time to go through today. Some of this follow-on content we'll have a subsequent presentation on. But the last area in paradigm shift that you all need to really be aware of is the shift to microservices. And of course, the hype is that it's a panacea. It's great. You need to go to it. The characteristics and the differences are depicted here on the left versus right, legacy versus cloud-native application environments. Monolithic environments typically utilize the waterfall development model. It shows you in that one box all the Jenga components together, tightly coupled, tightly integrated. You get great performance, availability, but if you want to deploy and update to any one of those software components, the process takes a long time. And that's why companies are pushing to DevOps today, and DevOps and containers go hand in hand with microservice deployments. So again, you need to do your diligence. This next slide shows essentially what microservices are. It's an instantiation of service-oriented architecture done right. And when I say that, SOA got a bad name with enterprise service buses and custom vendor integration software back about a decade ago. But this is software-oriented architecture composed of loosely coupled elements, basically individual services, individual functions of software that are deployed by themselves as standalone components within separate containers. And typically, it's going to be a small batch of code attached to local storage and given a REST endpoint. And I'm going to wrap things up by showing you this last slide on how things are moving rapidly to serverless computing. But if you can download this presentation in the future, I would recommend that you do so, because the last section does give you a summary of additional findings and recommendations and key challenges going through DevOps adoption, continuous integration, further emerging tech caveats, constraints, things like Internet of Things that poses a lot of new risks and threats and challenges by exposing devices that, again, are additional entry points that you need to guard and secure. And then the last section that I'd recommend you go through. We don't have time on this call, and I don't want to belabor things by reading through these bullets, but I summarized in this last section key business and organizational challenges that you're going to go through as part of digital transformation relating to those paradigm shifts we talked about, as well as the key technical challenges that you will encounter. And again, they relate to organizational changes. People are going to encounter reorganizations. People will run into a shift in control where operations for IT no longer exist. Cloud providers need to be utilized for those operational aspects. Control is going to go away for certain things, and shadow IT is going to pop up throughout your enterprises when you go through digital transformation. So there are going to be lines of business, there are going to be DevOps teams that want to do things their way at a very rapid pace without standards, without controls, and that's something that enterprise architecture and governance needs to address and manage. And with that said, I'm just going to wrap it up by giving you our website, techthought.org, a couple links to some articles that go into great depth around these topics. And I look forward to your comments, your feedback, and come back here to this link in probably a few hours, and you'll be able to download this deck. Thank you for your time. I appreciate it, and looking forward to future interactions. Take care, folks. Happy transformations.